my topic today is the creation of haptic proofs and in general how color management can be used in industrial printing. As you can see from my job title, I'm not really from the furniture industry or industrial printing. So to begin with, I would like to invite you on a very short trip into packaging, and you will see that there are some similarities, and a lot of the technology being used there can be put to use also in industrial printing. We've started to develop dedicated proofing solutions for the entire packaging industry about 10 years ago. And by now we have about 600 installations across the world, so we're probably one of the biggest or one of the heavyweights in that area. If you look in recent years, there's actually two trends in the packaging industry. Firstly, towards more sustainable substrate, and secondly, towards increasingly complex finishings. This could be, for instance, matte varnishes, gloss varnishes, reactive varnishes, and also embossings, as you can see here on the left side of this nice Russian chocolate packaging. You see some very delicate effects there. You see cold foiling here, and so forth. So the idea behind that is to not only create an attractiveness of the packaging itself, but to make the packaging tactile. So in other words, to appeal to the sense of touch. The problem is, as the complexity grows, it's increasingly difficult to communicate the end result of the final product just based on a purely two-dimensional paper proofs. So when you talk to the marketing department of your brand owner, there's typically a lot of explaining to do. So this area you have to imagine it's going to be matte varnished. This little logo there is going to be printed in silver, and that's going to be embossed, and so forth. So we have invested a lot into development and combined different inkjet technologies like UV or eco-solvent to exactly reproduce all these common effects you will find in finishing on a proof which is nevertheless color accurate. So in this way, a normal paper proof becomes a haptic proof, from which you can also generate, of course, a color accurate prototype, so your zero sample. But at this point, you might ask yourself, why am I mentioning this, and how does these developments relate to industrial printing, our topic today? And I would very much like to touch on this a little bit more. So my colleagues in the US, they are selling also the METIS scanner and the AVA design software. They have a few years more experience in this, but we also notice over here in Europe very often that the digital inkjet printing has really made an impact on the way you actually do your production. It almost caused a revolution in some areas. What we see is very often the producer who are using this technology, they perceive themselves not so much as printers, but they're manufacturers of flooring, for instance. But basically, the problems they arise from using digital inkjet technologies are exactly the same as you can see in commercial or in packaging printing. So to really assure a predictable, precise color results in the final printing, virtually at a press of a button, you have to establish a color management workflow. This ensures that you have uniform color across the board, across all systems being used across the entire production chain. This is particularly true when you run a distributed production on multiple production systems, regardless whether it's a conventional or a digital press. A particular challenge, not unusual of course, is to align production on different printing size to one common printing size on one common standard. For instance, we had one of the largest American laminate producers in America, and we managed to basically do so, to basically align them to a common standard across 12 production sites with a total of 6 offset presses and 16 digital production systems. So you see this here illustrated again. The goal should be to produce consistently and identical at different production sites over any kind of, over any period of time. This does not only mean your own production sites, so when you outsource your production, the challenge is the same. Get all of the suppliers on board and agree on one common standard. As I mentioned at the beginning, we're not just talking about purely digital processes, but also about classical printing processes. To put it simple, how can we make sure that what the designer creates can first of all be proofed correctly, whereby the proof obviously follows the capability of the production press. Occasionally also, depending on the production volume, a product has to be produced digitally and also conventionally. The other thing is also important, in addition, an objective color control and the possibility to verify and certify the result by management. That is very essential. And finally, of course, we'll talk about in a minute about this a little bit more, the possibility to produce haptic proofs. So as you can see here, we're moving really from a classic paper-based proof to a haptic proof, and finally to something I would refer to as the haptic proof 2.0. I think you can see this very good what haptic proofing is really all about in that context. So here are two examples of where haptic proofs come into play in interior design. So flooring, wall covers, whether it's in wood or a tile design. This, of course, only represents a small proportion of the market. Digital production gains more and more market share and gets into more and more areas in this thing. In addition to floorings or wall coverings, this includes, for instance, textured wallpapers or something like foam sidings. Very popular in America. You have metal home sidings and you put a wooden texture onto that one. Garage doors. And as of very lately, you also have now technology to, for instance, print on plastic or metal window frames. There's a Czech company called QRes, very famous for that, and they're getting more into that market. What I will not touch at the moment, or for today actually, is surface decoration in the automotive industry, which is of course a huge sector in itself. So far we have been looking at where haptic proofs are being used, and now I would like to get a little bit more into detail into the why. Actually, this is not much more different than packaging production, as I mentioned in the beginning. In addition to absolute color accuracy, the haptic proof also provides the look and feel. How does the structure, wooden structure for instance, appear under different lighting conditions, on different angles of light? What kind of influence to the final result, for instance, has a gloss effect? So using proofing technology, samples that can be physically experienced can be produced in the shortest possible time at marginal cost, accompanied by drastically reducing or shortening the approval process. At the same time, sorry, I got to go back on that one. At the same time, color consistency is ensured, virtually the step from subjective to objective throughout the entire production chain. So let's have a look at how and from what data such a proof is created. It starts actually with a 3D scan of the original piece of wood, which contains all the information, including not only the color information, but also the surface property of that piece of wood. So here we see a METIS scanner, which is used to generate mentioned color, but as well as the embossing or the structural data. The scanner can be used to register accurate deep embossing relief data, which can be processed either conventionally using, for instance, a gravure process with embossing rollers, or digital using a multipass process. So with CGS ORIS software, this scan data can be used directly or after editing to create a haptic proof, but also a conventional one. Conventional proofs still have a justification there. To a certain extent, you are also able on a two-dimensional proof to see certain information about the surface quality of a proof. So with CGS ORIS software, you can also use so-called big TIFF data, which allows you to at least simulate some textures in conventional proofing. So let's talk about how such a haptic proof is produced on a common inkjet printer, like for instance this Roland LEF-2 unit, very common in that area. It's a compact flatback printer which has a printable size of 330 by roughly 770 millimeters and a media thickness of about 100 millimeters. So it's also ideally suited to print on, for instance, like a laminate plank. So we're using these slices which come out of the scanner. They are referred to as slices. We're talking about the layer separations, which typically narrow to the top. And these separations are printed one after the other on top of each other. Typically, you're using either the white or the clear ink in the printer. And then, of course, as the final layer, the CMYK color is applied to the built-up structure. And that, of course, is based on a profile, so it exactly matches the production run. So here we see the entire process chain from scanning to the final quality control of the production. For us, our products provide opportunities to standardize and optimize processes throughout the entire production chain. For me, one of the most important measures is to bring discipline to the production processes. The most important thing is consistent color. 5 minutes, I matched that. The most important thing for me is consistent color production, as color is one of the most influential factors when you talk the success about a product on the market, irrespective whether it's like a furniture surface or a packaging. So here are a few key points of successful implementation in the process. First of all, the achievable color space of the production system, especially digital inkjet systems, have to be characterized, and a so-called fingerprint has to be created, which exactly describes the behavior of a certain machine-substrate combination colorimetrically. A standard must also be introduced in the design department, which can then be converted for production. Another important aspect, especially for decors, is defining a standard viewing condition, so the light temperature D50, D55, D65. Metamerism has also been taken into account. Where as of lately, we're also offering a new innovative soft-proof solution to cover that. Then, of course, the monitor for sampling to be used needs to have a decent color space and needs to be calibrated. Is the production within the specified tolerances? For this, objective criteria that can be measured must be defined, as well as control processes to objectively evaluate the result. And please, if you haven't done so, implement a proofing system. No matter whether it's a 2D or 3D system to start with, a lot of companies actually have both. So why is a reliable proofing system essential? A proofing system is always precisely profiled to the production run and also allows data to be reproduced at any time with deviations that are minimum compared to production systems. It's therefore a stable anchor in production and thus serves as the base for possible corrections as well as reference to the production. Since proofs are absolutely binding, they can also replace sample books or they can be handed out to end users as samples to keep. We have done this in the States. In America, some customers, they actually put proofing systems into DIY stores to do just that. And of course, as I mentioned, you can do either 2- or 3-dimensional proofs from 3D scans. Okay. Nowadays, the normal paper proofs are mostly produced on Epson printers that work with water-based inks and specialized proofing papers. These printers have a very large color gamut and are extremely cost-effective in terms of investment, but also in the ongoing operation. However, you can't reproduce gloss effects on it, or you cannot visualize real structures on a mostly semi-matte proofing paper. So haptic proofs can do this. They are really a true one-to-one sample of the final product. Okay? And these samples can also be printed on the real substrate. Okay, so I skip on my last thing, and thank you very much for your attention. I'll be